Welcome back to the Mr. G Computer Science channel. If you haven't already done so, hit the subscribe button to get the latest updates and give me a thumbs up for the video. The topic for today's exam question is truth tables and logic circuits. So let's just look at the scenario. A computer engineer has created the following circuit. Complete the truth table for the logic circuit above. So we can see in our circuit that we have three inputs, A, B and C, with the output of P. So the exam question has given us this table and I have put my solution using red text, but we need to show the progressive steps to get to the output of P. So to help the understanding of the circuit, I put these intermediary labels on the circuit. So the output of this NOT gate is NOT A, and the output of the OR gate is NOT A ORed with B. So I've created these additional columns on the side of my exam table. So NOT A column would represent the data value at this point in the circuit. The NOT A ORed with B column would represent the data coming out of the OR gate at this part of the circuit. Now we have the intermediate steps from our input to final output. So let's see how we generate the NOT A column. So whatever the value of A is going into this NOT gate, the opposite will come out. So if you look at the data in the A column, the NOT A column is an exact opposite. So now let's look at our NOT A ORed with B column. So we look at our NOT A as one of the inputs to the OR gate and the B as the other input to the OR gate. Any existence of a 1 in those two inputs will yield a 1 output in the NOT A ORed with B column. So that's our internal outputs within each of these two logic gates completed. Now we can use these internal columns to complete the output for P. The output of P is the output of an exclusive OR gate, and the two inputs for that gate are the NOT A ORed with B and the C column. Now an exclusive OR gate is also known as a difference gate. So where we see a difference between the two inputs to an exclusive OR gate, we will see a 1 output. So let's look at the first few rows. C is a 0. NOT A ORed with B is a 1. Therefore we have a difference of the two inputs. Therefore the output will be a 1. C is a 1, is a 1 here. So the two inputs are the same. So the P output will be 0. C is a 0. NOT A ORed with B is a 1. We have a difference. So P is a 1. C is a 1. NOT A ORed with B is a 1. Therefore there's no difference. So P is a 0, and so forth. So by using these two internal columns internal to the circuit, it helps us break down the stages of getting our three inputs to the final output of P. And I recommend that any pupil sitting exam questions where they have a table which only represents the inputs and the final output column, that they add these additional columns in to support their calculations. The second part of the question asks us to give the Boolean equation that represents the circuit above, and it's asking us not to simplify the equation. So we have A going through a NOT gate, which is then ORed with B, and the output of that equation is exclusive ORed with C. Now other alternative ways to annotate Boolean equations use these symbols here, and another alternative are using these symbols here, and this depends on whether they have a more engineering or mathematical bias. All three of these answers are acceptable when it comes to the exam. Hope you enjoyed the video. Don't forget to hit the subscribe button to get the latest updates, and give me a thumbs up for the video.